Let's have a quick look at some application problems with trigonometry that involve bearings. Now there are actually two types or two ways of describing bearings. There's the conventional method, and that conventional method, if we draw a compass with north, south, west and east showing, and let's just say we wanted to look at this bearing here, that red line, we can describe its bearing as a conventional bearing by choosing north or south, whichever is closer. In this case, south is closer, so from south we would need to move 60 degrees towards the east. So we write that as south 60 degrees east. So these conventional bearings start with either north or south. Let's have a look at another example. In this case, the bearing here along this red line is closer to north, so I start by facing north, and from there I would need to move 76 degrees towards the west. So I write that as north 76 degrees west. So to recap, conventional bearing positions start with either north or south, whichever is closer, and then a bearing in degrees towards the east or the west. Now the other method to show bearings are called true bearings. So this was thought to be a simplification because we always start at north, and so there's no need to even write N for north. We're always going to be bearing clockwise. So if we look at an example here, or two examples, the first example, we can see that this bearing, to get to this bearing, starting from north, we would have to move through an angle around to here. Now, the angle we have to move through in this case is 90 degrees to get towards east, and then another 30 to get to where our final position is. So that's a total bearing of 120 degrees from true north. Now this one here, remember we have to move clockwise, so from true north we have to do more than 3/4 of a circle turn. So we have to do the 3/4 turn of 270 degrees, and then another 50 takes us to 320 degrees. Okay, so what's happening over here? We've got an example here. We've got a boat that sails on a bearing of north, getting a bit lost here, a boat sails on a bearing of north 30 degrees east for 7 kilometres, and then changes course on a new bearing due east. That means directly east, for 10 kilometres. How far is it from its starting point? Well, let's have a closer look at that diagram. So we start with our first bearing, which was on a bearing of 30 degrees from true north. So I move through 30 degrees and I draw a line which is 7 units long, representing the 7 kilometre first leg of the trip. From that new position we now move on a new bearing, so we draw a new compass point centred on our new starting position. From here we're going to move directly east 10. So our finishing position or final position is here at C. We want to work out how far we've travelled altogether, which is this distance here. Now if I label the triangle as A, B, C, you'll notice that the distance I want to find is distance lowercase b, because it faces this angle here. Notice that I have two sides here, 7 and 10, and I can work out the included angle here. How can I work out the included angle? Well, I know that this bit's 90 degrees, but what about this bit here? Notice the dot here and the dot here? That's right, those two angles are the same. They are alternate angles. If I trace through here to here to here, you'll notice I'm tracing through a Z, or a back to front Z. So that 30 and that angle there is also 30. This 30 and the 90 make 120 degrees. I've redrawn the triangle down here to show that 120 degrees. Now, which rule should I use? I can't use SOHCAHTOA because it's not a right angled triangle. Can I use the sine rule? No, because I don't have an angle and the corresponding side. So I use the cosine rule. Two sides and the included angle. So the side I want to find, which is B, I'll use b squared equals a squared plus c squared, so that's my 10 and 7 squared minus 2 times 10 by 7 times cos of the angle 120. I get 219 for b squared, so I need to take the square root of that and I get 14.8 kilometres.